All right. So let's start here with group tree automation. So welcome to the group tree automation by Monty and me. You should be pleased now. It's if you didn't do it already, tinyurl.com/9pros-stuff. If you can, Monty, share this link on the chat. It's really important. But if you go on app9.com and you write 9pros Learnathon group tree, you should be able to find our examples that we're going to use tonight. So while Monty shares the TinyURL link that we are going to use to download all the materials, I will go on KNIME app really quickly. There we go. And I'm going to here write group tree Learnathon 9pros. And you can see here that you should find already the solution, but if you select the group tree automation here, and then you click this download button, you should be able to download everything. So I'm gonna write this link in the chat as well. So the Dropbox has everything, but if you want to download only the workflow right away, you go to this link I just shared to you, and you're going to click this button here, all right? This is the button. If you click the button, you should download a KNIME file that you double click, you open a KNIME, and you can start working with exercise with us. I'm sorry about the Dropbox. We will send you the slides via email, Michael, but if you go on the app, you should be able to get the book. And yeah, Monty, please share the codes of the book. You should be able to find it in the slides. And let me know, can you please write done when you have imported the app workflow? So again, you go to the link I shared before. I'm gonna share it one more time. And then you are going to click there and then download all the workflow using this icon here. I'm moving my mouse, see it? When you download it, your browser should download the workflow. And then when you open it, you should be able to import these exercises. All right, so group tree, I'm starting now. We have lots of stuff to show you. Don't worry, the recording will be provided afterwards. If I'm going too fast, I hope I can slow down, but there is lots of stuff I would like to show you. So right now, we're going to start with configuration and logic. Oh, sorry, I missed a few slides. All right, so few slides. Automation category. What is the automation category? We have lots of components that are made to automatically train models, to automatically perform parameter optimization, get out metadata of workflows. So the automation is a really big topic. But the topic that I would like to focus here about automation is AutoML, automatically trained machine learning models. So I think it was when it was last August, we released the AutoML component. This component is available that you can use it only for supervised classification, binary and multi-class classification. Your target must be string. You select all the models you want to train, all the features you want to have, and you can then go ahead, select things, click OK, and the model will be training. And then the crazy idea is that once the model is done, it's exported in a way that can be reused with a workflow executor. So the idea is also that it has an interactive view, and the interactive view can be used to understand exactly what happened inside this complex AutoML procedure. And today we're going to see a bit how to do a tiny example of this really complex component. So the component has many nested components in it, many configuration nodes to set up the dialog, and many integrated deployment pieces to decide which part we should export to define the last model. You can find a blog post if you search for integrated deployment online, and this blog post will give you all the details about the component. The idea is that once you write with a workflow writer the output of this component, you get a workflow, and the workflow is in the end the model. We showed this in the last track with the with the Phil, and hope you enjoyed it and you were there. Okay, so the interactive view is a key part of this to be able to understand what happened inside, what is the performance of this model, or what they're doing, change the selection of which model should be retrained and re-exported, and all of this is possible via the composite. Now, today we're going to focus on a simpler example. It's still an AutoML component, but it is for regression. So the idea is that we are not training anymore binary and multi-class classification, but we are training a few regression models using that is a double target. All right. At this point, we will have 3 activities. First activity, how to build a configuration dialog for such a component. Activity 2, how to capture just the little model to be exported. Activity 3, how to create an interactive view to be able to see how the models perform, what is the model performance. And again, this is a simple example, but it gives you an idea of what you will be able to build if you learn these kind of tricks. All right, so now let's move again, you can, I guess many of you already imported exercise, and I will now move to the KNIME and start building the exercise. So first activity 1, building the configuration. Let me open this a bit bigger, okay? And we can execute this data access view. Each activity, we're going to change data set, so to make this even more robust. So first data set, it's going to be about a telco, and we have for each customer how many minutes they were on the phone on a day, a night, in the evening, and so on. And with all this data, we want to predict churn, whether they will churn or not. But, oh, sorry, this is I just put the automated message. No, we are not predicting churn. Churn is a classification task. We want to do a regression task. So just to do in a different way, we want to predict the account length based on those features. And or any other feature, right? We can do whatever we want. It's just a data set in here. So we are here selecting the component. We can, if we double click, it doesn't open the configuration dialog because we need to build it. But you can execute it. You can right click, execute the component, and you can even open an interactive view to see what's happening. If you open the interactive view, and this will be activity 2, you can already see that we are building those models predicting the account length of those telco customers, which is they are not doing so well, are they? Here we are sorting the ground truth by the least value to the greatest value, and we are trying to see if this shape is also followed by the different models. And you can see they're all the way in the middle, and they are not doing that well. Not even if you zoom in a few, they're not doing that well. But we are training something. So how did we can we control to, for example, target something different? So you need to go inside the component, and then open. We are now inside the component, and you should see here the instructions. As you scroll down, you should see also the workflow. So that's what we're going to do a lot tonight, this morning, depending on your time zone. We are going to go from activity 1 and read the instruction and go down here and apply those instructions to our workflow. How does our workflow looks like right now? We have a component input where the data comes in. We have some hard-coded flow variable that is being injected. And we have a partitioning between train and test. Then we have here all those models being trained, an interactive view, and then the best model being exported out down here. All right, so this is the component, and now we need to select a few settings here. We want to change to make this configurable, and we need configuration nodes. So the first node we will need is called column selection configuration node. Always keep an eye on those color tags here. Those are the names of the node. So you go in node repository and you call column selection configuration node. There it is. This is the one you need. column selection configuration node. And we have here a few settings that we need to set up in order to make it work. This will be the node that we need to select the target of our regression. So now we can take this and move it down, all the way down here. Here we go. This is only for placeholder. We'll just move it up. And here we build our configuration node. I'm going here to drag and drop it and connect the common selection configuration node. Then I need to configure it. It's all the same in KNIME, drag and drop, connect, configure. And we are going to configure it here and say here, select target. Here we're going to say, please select numerical target for regression. You can write whatever you want, guys. It's just to make it clear, an instruction. Now, here it's important that instead you need to be really precise. You need to write here target underscore column. This here is the target of our regression, and it's going to be the name of the flow variable. All the nodes downstream are expecting you to write this precise flow variable name. So I'm going to select here target column, drop down, and I'm going here to select to only allow number double and number integer, because those are only the kind of task that we want to do. Predicting integer, predicting double, those are number columns. All right, so I selected those two. I think that's good enough. How do I know if this worked? How do I know that? Well, it's not connected yet, right? But what I can tell you is that if you go outside on the main level, on the main component, and you double click here, you're going to see here that I can select the target, right? I can select target, and here only integer and double features are provided. So this is the first task. Let's now move to the second task. Multiple selection configuration node. Again, I go here and I type in here, multiple selection configuration. Drag and drop the node. And here I need to call it in a different way, but it's rather similar to before. So I go down, I drag and drop it all the way down, and I place it here next to the select configuration node. And here I need to say model selection. What do we write here? Please select the models that you would like to train. Right? And here we need to be really precise on how we call this. So let me go back up a second. We need to call this selected models. So you need to go here and call it selected models. So selected models. I will also take this flow variable name and post it in the chat so you guys can copy paste it. All right, so selected models is here, and now I want to also select, for example, checkbox vertical to select which model I want to train. So in this case, I know already we are training today a gradient boosted trees, gradient boosted trees. Then we are training a polynomial regression. The order doesn't really matter tonight. Polynomial regression. And then we are also training linear regression. And I think only a random forest is left. And by default, I want that all of them are selected. So like this, I select all of them. So when I click OK here, what's going to happen? That if I go on the outside, and for example, I select here that I want to predict, let's say, what I want to predict, day calls, or even more like, let me find something, day minutes. And those are the models that I want. I can deselect a few of them. And as soon as you click this and you execute, you will see here on the output, target column day minutes. And you will see here when this executes that you have only linear regression and random forest selected. So it's important, you change the setting on the outside, the nodes on the inside will change their output once executed. Okay, great. We have the two nodes. What else do we need now? Maybe I can copy paste this for you. For the ones of you that are configuring nodes, as I go through this, I will try to copy paste things so that you can follow me along. All right. You have to rename your last configuration again. Your last configuration. I don't know what you're talking about. We'll find out later if something doesn't work. Okay, so here I am. Oh, the variable name. Oh, you're right. Thank you. Selected models. Thank you. It would have taken me some time. Live demo and live solving of exercises. This is all being recorded, by the way. All right. No, I should be fine. Let's now go through the next step, which is called string manipulation variable node. So I go in here and I call this string manipulation variable node. Why do I need this node? Because I want to change this variable to also know not just what is the input feature, input target feature, but also what is the output of the model. And what do I do this? I need to define here how it's going to be called the predicted variable. So in here you can see it has to be called prediction underscore target. And then I need to also maybe write here something because I need to go back up. So prediction underscore target. And the other thing here I'm doing, I'm joining here prediction with a target column. So what does this mean? Is that I will also copy paste it for you so it's easier. So I'm going here to create a new column name, which is prediction space open parenthesis, and then here the name of the target column, and then here I close the parenthesis. So I'll copy this and execute. So once this execute, you can see that I create a new variable, and this variable is called prediction target, prediction name means. Why did I do this? Because we are going to have to know how we need to look for the target, the output of the models. This will be used downstream the workflow. Okay, great. So this is the string manipulation variable node. And then we have another node that we need to add. Oh, sorry, I need to post this in the chat. Oh, and gone, I need to copy it again. And there we are, chat, and then I paste this. This is the content of the string manipulation. All right, great. So what we need now? The breakpoint node. Breakpoint node, this is important. Let's say that our user is just being stupid and he wants to execute the node, the component, when no model is selected. So this will mean that it's not possible to execute the component if you do not select not even one model. And so the breakpoint node will be able to detect this. How do we do this? We connect the breakpoint node. We double click here. Then we are going to select breakpoint enabled. Then we're going to select here to fail if it's on empty table. That's good. And then here we can say here, please select at least one model. So let's see if this works already. Let's now go out of the component and let's select here to not select any model, like this. Now I try to execute the component and it should fail saying, oh, wait, I think I copy pasted this node before by mistake. So let's try again. Here, you see, please select at least one model. And this because it's this node failing here, and this node the message is going out. All right? So this was the breakpoint node. All right. Any question about the breakpoint node, these four nodes? How are you guys feeling? All good? Tell me if you're fine, all fine, or you're feeling fine. Yes? All good so far? All good? Okay. Thank you. You know, I'm not like in front of you like we used to do in usual summits. All right. All right. Nice. Many goods. Many thumbs up. I'm super happy about thumbs up. All right. Let me get rid of my sweater and let's keep going. So at this point, we need to add another node, which is called extract variables data node. So extract variables, it's about extracting the variables that are here in order to select it. So let's go back here and please select at least one model so that we have something to train. And now this is not failing anymore. And this other node is only to make sure that we get a flow variable out of this. In fact, we get selected model gradient boosted trees, the only one selected. And the reason is that this model here was already flow variable exporting this. Why do we need a flow variable here? Because we need to inject in the flow variable. We need to delete here the placeholder at this point, and we need to have a merge variable node. The merge variable node will help us connect those two together and then inject it into the flow. Of course, I already got those ready for you, so now everything is done. Let's see if this works. Now, I select here to train only gradient boosted trees and to predict day minutes. Let's now execute an open view, and let's see if we were able to do this. Yes, the component only trained the gradient boosted trees, and probably there is some huge ground truth leakage because it was able to match perfectly and make a really good prediction. Look at this. If you look at the two are basically identical here. There is really a really small error compared to what we were trying to predict before. But it works. I changed the day minutes and all the flow variables now are being correctly installed in the flows, and they're changing the settings of all the downstream nodes. All right, I think. All right, so at this point, I would like to move to the next part, unless you have any question, which is the more interesting one, which is the capture workflow node. So if you have any question about this part, this is the right time. All right, I don't see any question. If there are any questions, please ask question. Monty is here to answer all your questions. All right, Monty? Okay, so let's now go to the activity 2. We open back the exercise, we click group 3 activity 2. Now, here we have a different data set. If you execute this data access view here, you actually see that we have wine data set. So each different row is a different wine, and we have the alcohol, the density, the pH, the sulfates, and so on. And let's say that, for example, we want to here predict with all the models, we want to predict the alcohol. All right, so I can execute an open view here, the AutoML procedure here, and it's only training a gradient boosted trees. Why? Because we need to now do our job and adding all the models. So how do we do that? We can go in here, and now we need to do the, you see the dialog now, it's filled in, but what is missing now is this part in the middle, which is adding the models, the nested components training the different models. All right, and we need to start by capturing the gradient boosted trees, because right now it's not captured at all. You can see it's only spitting out a row with the performance. We want to have the model being captured there. So how do we do that? So first of all, you need to go inside the gradient boosted trees. So right click, component, and open. Now we are inside another level. So there is the main component, the nested component. Now we are inside the nested component. And we want here to work on this part. So this nested component is somewhat complicated. What is it doing? It's, first of all, having a string to recognize which model is this. So let me show you from the outside. Of course, we have only 1 hour today, so I try to make this as easy as possible. So the meta learner has a configuration node itself. So we are talking about a nested component with a configuration node itself. And is expecting here that you write gradient boosted trees because we are training a gradient boosted trees now. This variable that is inside here is being used to check whether the user selected gradient boosted trees, because there is here a rule engine variable that is checking whether in selected models there is the word that was in the configuration node. So this is the logic, right? If the user selected gradient boosted trees, inside the string containing all the names of all the models, I should find the word gradient boosted trees. If so, 0. Else, 1. If 0, I'm going to train the model. If not, I'm going to not train the model. So if we want to see this in action, let's do a trick. I'm going to keep this on the side, and we're going to go back in the main component. So right now, you can see that the model is being trained. If now I go here and I say that I do not want to train the gradient boosted trees, and I re-execute this, you can see they didn't train, right? Now there is no other model, so it's failing, but the point here on the right, you can see that it was deactivated. If I go back here and I select gradient boosted trees again and execute again, you can see here that instead is going green again because the port is activated. Same thing goes for the data going to the capture node. So this is the train data, this is the test data. Okay, we are all 9 pros here, so I won't take it too slow. It's now time to capture our predictor node. So let me go to full screen again. There we are. And we are now capturing this predictor node in order to export it. How do I do that? I need to add a capture workflow start node. And please make sure you install integrated deployment to do this. You need to have capture workflow start. You drag in this node, you click on these 3 dots, you see the 3 dots here, and you say add data. Now we add here those 2 ports, and I'm here connecting like this and collecting again. So what this does, it says this is the start of the capture function. This is the start of the function that I'm here collecting in order to be exported, which is basically the predictor node. We could add here many data preparation steps, but we are not, because it's a simplified exercise. Now, let's now add another node, which is the capture workflow end, and I will add it here. So I here add another data port, and I connect this to this and this to this. All right, so we added this node, and what does this mean? What did we do here? Well, we captured this node, and this means that this port here is storing the workflow between the start and the end. This means that if I go here and find a workflow executor like this, and I connect this to the workflow executor, I can go inside, auto adjust, and then I can, for example, take all the train data and execute. And what I get in return, I get the predictions. Magic, right? No, it's simply executing those 2 nodes on this data here. Okay, was the concept clear or not? I would like some feedback if possible. I can go all over again if you want. So we are capturing here the predictor node, and then we can reuse it using this output port. VJ, awesome. Amsa, Michael, yes, okay. Someone can write no. Also, no is fine if you want to write no. All right. All right, so if you want help, you can also single message Monty and he will help you. All right, you can single message him. You don't need to always shout in the public. All right, you find everyone, and then you go and single message Mahantesh. There is KNIME in front of his name. All right, so let's keep going now. I want to store this workflow I just captured, and I want to store it inside the logic. So what I do here is I delete this placeholder here that I had in place, and I'm going to connect this here. So this switch is either attaching basically a null model, or is attaching the workflow, the model itself. So when this is executed and the user wanted to have a gradient boosted trees, then the model is stored, is then converted to a row, and then is then is the output of the meta learner. So if you go here at the output of this, oh, sorry, I went too far out. You are going to have one, the predictions of the gradient boosted trees coming from the top port of the capture end. And here you're going to have the trained model coming from the bottom port of the capture end. And now we want to do this again and again and again for different models. We don't need to build everything from scratch. We can simply copy paste. So you need to copy this meta learner and paste it 3 times. 1, 2, and 3. And we are going to have now all the other different models. So you delete the placeholder, and you're going to have here all the other models that we want to train. The logic is always the same. So here we have gradient boosted trees. Let's say we train here a random forest. Then here, what do we have? Here we have linear regression. And here, what do we have? Here we have a polynomial regression. Of course, we also need to provide data. So this is also important. Train data, train data, train data, and also the test data. Test data, test data, and test data. All right, so we attached all those meta learners, and we all simply call them random forest, but they're still gradient boosted trees, right? Inside, there is still a gradient boosted learner node. How do we take this node and replace it? Well, we need to go inside and edit the component. But first of all, we need to activate each of these components only if the user selected that model. So we need to here change here this configuration. So here I'm going to write, I think this was random forest. And here I'm going to write linear regression. In here, I'm going to write polynomial regression. So what does this mean? It means that now those meta learner will execute only if the user selects the random forest, linear regression, or the polynomial regression. If it doesn't check the box, they do not train anything. Okay, but what do they train when the user selects? They train a gradient boosted trees. We want to here have random forest. So step 1, we need to go here and take the random forest learner node, not this one. You need to get the regression one. Regression, because we are doing a regression. So you drag and drop the regression one, and you're going to replace it here. And then you take the random forest, not learner, but the random forest predictor for regression, and you're going to drag and drop it here. And at this point, we are almost there. We only miss one thing. The random forest regression doesn't execute on its own. It wants to know which target it should have, right? Because it wants to know which is the target. But the target is not selected only once. It has to change. And it's really important that we're going here in flow variables, and we're going to select here target column. Because again, we don't care to select here one column. The data will change, and this selection will be useless. We want to go here in flow variables and select target column. Why target column? Because this target column is created on the outside by this node here, which is changed by the user. Right now it says alcohol, the random forest will train alcohol. Tomorrow it will say something else, and the random forest will be updating its settings. All right. I hope everything is clear so far. So now I'm going to do the same again and again and again. So now we have a random forest and now executes. Then now down here, we need to have a linear regression. So I have here linear regression learn, drag and drop, connect. Now, most of you will be now saying, this guy is doing AutoML without any parameter optimization. It's true, this is an exercise. If you wanted to have parameter optimization, we would have add another component on top with another partition of data. There is no time, but please check the AutoML component we already released to do parameter optimization with cross-validation. I think there is a question in the chat. Capturing workflow is a great idea, so we don't need to the pre-processing part what we have to do when exporting the model. So the workflow capture nodes include model we used, and does it work for other models apply, like normalizer apply? Absolutely. This way you can capture the preparation, and the only difference is that you capture, and then you use a node called workflow combiner, and the workflow combiner will be able to combine the predictor part with the normalization apply part or whatever you want to combine here. So that answers Armin questions. All right, let's now keep going. As there isn't much time, we still have around 25 minutes. So let's keep going. Linear regression learner. The linear regression learner is really similar to before. We need to have the right predictor node. So we go back in and we are going here to write the predictor for regression. I think it's called regression predictor. There it is. You need the regression predictor node. As you can see, we can capture this one as well. And this will be captured by integrated deployment. Again, we need to tell the linear regression learner what to train on. And to do this, we need to go in flow variables, target, and again, target column. And click OK. All right, so at this point, we train another models and we can execute. Nice. And we need to do the last part again with the polynomial regression. So we go back down here and we are going to add again the polynomial regression learner and the regression predictor. We connect the two, and here we go in flow variables and target column. Great. All right. So if this worked out, how do we then send all of this out? So you can now execute all of those, and we need to put all the output together in order to visualize it, in order to decide which is the best one. So to do this, we use the column appender node, and we're going to add more ports using these dots here. And we're going to add all the ports here. 1, 2, and 3. Then I'm adding another input here and adding this one here. So now when I execute this, oh, sorry, I missed one. And 1, okay. So why did I do this? Because now I have all the predictions of all the models here. We rename the output for all those models, and you can see I have the prediction for gradient boosted trees, the prediction for random forest, the prediction for linear regression, the prediction for polynomial regression, and the ground truth. Where is the ground truth coming from? It's coming from this column filter down here. This is the ground truth. All right, but another important thing is to also keep the model in. For this, we use a concatenate node. So again, we add 3 more ports, and we are going to drag and drop it, the 3 nodes. So now, if you open this, you're going to have all the models. So let's check if this actually worked. So now, if I go here in the settings and I say that I only want to train those 2, and I want to predict, I don't know, let's say pH, and I execute, and I open here, I should see only the one I selected with pH. Nice, right? I can, of course, here explore the data and select only one and see whether this worked or not. And if I select another one and go back to, I don't know, alcohol, I click OK, execute and open view again. And I have then now again alcohol, and I have 3 models instead of only 2. Now, the idea here is to export a model. Now, what do I have here? I have a row with some weird stuff. We need to export this workflow object here. How do I export it? I need to change the port. So to change a port, rule number 1, you cannot change a port if it's still connected. So please disconnect the port, disconnect. Second, once the port is disconnected, you can then go in component and then set up, and then you can delete the port, and then you can add the workflow port object. Click OK, finish. Now you have a workflow port object. You do not have this feature if you do not have integrated deployment installed. So once you have integrated deployment installed and you have this port here, we need to connect this here, and you will be like this. Oh, it doesn't connect. Why doesn't connect? To connect, you need to convert again from this data format to this model format. And to do this, there is a node that existed before integrated deployment. It's called cell to model. So you take this, you drag and drop, you connect, and you connect. And you need to open the settings here and select port object. Done. And now we have the best model that was selected this way. And we need to do activity 3 to understand how to select the best model. Let's see here if there are any questions. Okay, I see that most of the questions are answered by Monty, and I can see we have still 23 people in the call, so that's also that no one got overwhelmed. So this can be then reused again and again, the best model, again, via a workflow executor. But how did I select the best model here? How did I have a single model to be exported? So you can see here that I have the prediction of it. The best model was selected because here in the performance view, we compute the root mean square error. Then we are using a joiner node to make a leaderboard of the models. Best model here, gradient boosted trees, row filter the top table, export the model of the top table, of the top row, done, we are done. Okay, so we need to go now to activity 3. We still have some time, and this is maybe the most fun part because we're going to build the interactive view. Is there any question regarding capturing nodes and so on and so forth? Yes, Keegan is asking, can you talk a bit about the workflow executor? I don't really get why you're using it every once in a while. All right, so the idea of the workflow executor is to actually reuse the data. Now, in this case, it doesn't really make sense because okay, so let's be super clear. We created here a model, a component that takes data in, trains stuff, gets a model out. Is it clear so far? Data in, train something, models out. Now, with this feature, you have a sort of a learner node, right? Because you're learning and you're spitting out of a model. What is your predictor? How do you create a predictor? How do you create something that is able to reuse the model and execute it? So like any predictor node in KNIME, you use the workflow executor. This is your predictor. Now, in this case, the predictor, I'm using it on the same data, so it's not super useful. But if, for example, I'm partitioning here with this node, right? I'm giving 80% of the data for this, whatever, let's just use draws randomly. And we give 80% of the data to the learner, then I'm able to score predictions on data that none of the models that was trained has ever seen before. It's like if we create another partition on top of the partition. And so those predictions here, it's like if you have a predictor with those predictions, and if you, for example, want to measure the quality of this, you will need to add the ground truth, and then you can remeasure the root mean square error and actually know how well this model did. Okay, so now it's clear. Let's now move to activity 3, unless there are any questions. Activity 3, opening here, activity 3 now. All right, so now we have a model that is able to train all of this stuff. It has a configuration panel, so new dataset first, new dataset. The new dataset now is the iris dataset. I think if you've been in data science for a bit of time, it's a dataset, a flower for each row, and we have sepal length, sepal width, petal length, petal width, and there are different species of flowers. Now, let's use one of the numerical columns as target and the other ones as features. And what we get is that we can train all the models because we work on the configuration part. We can select, for example, sepal width, and then we can execute. And then what happens here? I get a model. What is this model? On the outside, I do not have the view. The view you see is grayed out because we need to, in this activity, build the interactive view, the information that we get out of what was trained. Okay, so we control, double click, we go inside, we have all the instructions here. And in these instructions, we are going to see how we build the interactive view that is telling us the performance of the models. All right, great. So I'm happy some people in the crowd can relate to the data set. Now, let's start with the first task. Up here, let me read because I do not remember everything. Constant value column filter node. We want to get rid of models which always predict the same things. Sometimes it happens, so we want to get rid of them. So we are going to here have a constant value column filter node. This one is attached to the prediction, and we get rid of columns which always predict the same thing. Nothing else to do. It's just a quality check. Otherwise, the visualization goes crazy. Next, we want to add a sorter node, and the sorter node is going to be the first branch that we create. The sorter node will sort all those predictions by ground truth so that we can make the nice line plot. So we have here the sorter node. We drag in the sorter node, we to connect, and it's really tempting here to just say, here, select ground truth. Okay, what is the start ground truth? Sepal width. Okay, done. You're done. You're not done. It's not just by selecting the target that you're done. You need to select the actual target column here in the flow variable panel. Otherwise, this node will fail as soon as you change your data in the component. So remember, whenever you select something that is going to change with new data, then you should change this this flow variable panel. So again, you can select maybe to have them ascending, like the lines were always increasing, right, in the line plot. And then we have here the flow variable, including list target column. Okay, great. So now this will sort no matter what target column we have. Next, we want here to have a counter generation. The counter generation node will just give us some easy way to plot our data with 1, 2, 3, the order of the rows. Counter generation, it doesn't do anything. You just execute it. It creates a new column. So at this point, we have the data that is sorted by sepal length, the predictions next to it, and a counter 0, 1, 2 from the smallest sepal length to the biggest sepal length. Nice. Next, we want to have a interactive range slider filter widget. This is the longest name ever created for a node. I always complain to the developers, but they really like really long names. It might be a German thing, but I'm not super sure. So interactive range slider filter widget node, you open here this node and you can select the sepal. What do we want to filter by? We want to filter rows by how many rows we let in and out the visualization. So we leave counter here. There is nothing else. You can say here something like the label on top, and we write here rows to filter, something like that, just to give an hint. Okay, after the interactive range slider filter widget node, we have the line plotly node. You need to have plotly installed for this. So here we go all the way to the right, and we have a line plot for plotly node, and we add it right here. We connect the node, and here we need to select everything beside counter. So now this is an important concept that it's all over the place, but I want to use it here. So what flow variables do I need to set up here? Well, if I'm careful enough, I do not need to set up any flow variable here, even though the data changes all the time. Why? Because x-axis column is counter. Counter is always the same. Those models are in a list, and those are in another. Counter, here again, never changes. What matters is that we enforce the exclusion on this list. Then here, if the name of those columns changes in number, in the fact that we have a different target, a different amount of models, the node won't fail because we are enforcing on the counter here. So if I do this, I change the data, I change the models, the node fails. If I do this, I change the models, I change the data, doesn't matter, the line plot doesn't fail. Really important. Okay, so we can see already if this worked, we can open here the visualization and we can actually see the pattern of the predictions on this sepal length on the data. And so we can see that it's already working. Something really nice we could have is the name of the models. This is again in the line plotly. You need to go here in the show display legend. You see here, display legend. You click that and the legend will be displayed. So here we open again, and you can see here on this part here, you can see the actual legend. Okay, awesome. So let's now keep going, and let's now add another branch. How much time do we have? Oof, we have 7 minutes. All right, so here is the loop nodes. Loop nodes to go through each of the models and measure the performance. So first of all, we need the loop start node. So I go here and I write here loop start. I select here the column list loop start, and this is useful to go from here through each of those models. Let me move those guys down here because they are in my way. Okay, so here I select after removing custom columns, I want to go through each of those models and measure the performance. I'm going to select all of those models. No, this is not a model. This is the ground truth. We keep the ground truth on the left. we are keeping only him on the left, so we need to put a flow variable. Exclude column names, again, target column, so that always the target column is excluded from the iterations. The target column is not a model, so we do not need to measure the performance for this model. Okay, so now we execute the column loop list start, and we have the first model, gradient boosted trees. Let's measure the performance of gradient boosted trees. So to do that, I need first to get rid of missing values, otherwise it becomes just messy. So missing value node, we apply the missing value node, and we're just going to remove all the missing values and replace them with a min. This is only an example, simple. Maybe there is a better strategy, but for now, this will do. Then next, we want then to apply another thing, which is the numeric score node. So we go here, numeric score node. This is what is computing the root mean square error that we have seen all over the place. So we go here, and here, huge temptation again. I just select reference column, sepal length. I select here, gradient boosted trees, done. No, it's not done. You need to use flow variables, otherwise this node will fail. So how do I do that? I go here in flow variables, I go in reference, I go here in column name, I select here current, this is the reference, so this is the target column, and then I go in predicted. The predicted is instead the current column name. What is current column name? Current column name is created by the loop node. Every time, every iteration, it will have a flow variable that changes the name of the column that is currently being iterated. So this column, this flow variable changes, the settings of the numeric scorer changes, the performance of a different model gets computed. Really important. Okay, so at this point, we are measuring here all these kind of statistics. Those are way too many. Let's just pick one. Let's say row mean square error. So I'm going now to select the row filter, simple row filter, and I'm going to connect it here and select here to only include by row ID, and I say here root mean squared error. I just say, just take this row ID and this row of this row ID. So after filtering the data, you only have one metric, row mean square error. Great. Then I need to transpose the data because I really need to collect each different model as a different row. Otherwise, it becomes too complicated. So what now we have is that row mean square error is the column, and gradient boosted trees is the row. And so when we collect this data, it will become a table. First row, second row, third row, fourth row, each time iterating. So now, if I select a loop end node, there it is, the simplest of the loop nodes. This is only for each iteration collecting data. So if I simply execute it, it's already working. We have for each model the different root mean square error. We just simply re-execute this set of nodes each time on a different column, and each time we measure a different performance. Great. There is a few things that we can get right is, for example, leave row ID set modified because we need to have the pure names of the models. It's always different, so for different models. And then we leave the iteration, we do not want the iteration column. So now when I re-execute this, it's even clearer. We have, let me zoom here a bit. How do I zoom? We have gradient boosted trees, one for each row, and we're going to have row mean square error for each. So as you can see, we have those. Now, which of these is the best one? The one with the least error, right? So we want to have a sorter node. We have a sorter node, and now we are sorting and getting the one that is, we need to have it descending, so we have the best one out. All right, really important at this point. Let me go here back so that there is more space. I have all these cameras here on the side. So now we sorted the table from the best model to the worst. What can we do? It's a dashboard. We could have a table showing this. So we have here a table view, and the table view will show us the collection of models we have. Now, this is a simple table. There is so many features here that are overkill. So we do not have row colors. We have row keys, we have column headers. Full screen is a simple table. We don't need that. Interactivity, pagination, it's a simple table. Selection, it's only one. We don't need it now. Enable searching, off, off, off. Okay, I took many of them off. And the table view is now having a really pretty, simple table with the models that we trained, right? The best one was gradient boosted trees. The second best was polynomial regression. The third best was random forest, and so on. Great. So now we have all those different models that we train. What do we want to do now? We want to create a dashboard. So first of all, let's export the data so that we are able also to export the best model. How do we do that? We need to have a joiner node. We need to join the data that we gathered with the model that we captured. Model that we captured, no, sorry, performance that we gathered, model that we captured. And now we're going to have here we want to use here the model as for the joining. And finally, if we connect this to this, the table should still be sorted. So we are going to get the best model out. Right. Now, the third and final step is to take all of this stuff, all of this, right-click, create component. Click OK. Interactive view. We have our interactive view. We created our interactive view. And we can go inside, still find our interactive view, and decide a bit how it's going to look. We can put, like, for example, on the sides, we can have like a bit of padding on the side, the line plot here. Then we can have the table view here and the interactive range slider here, making a bit like this. You can also make this squared, for example. You click finish, and then we're done. We now execute and open views. Oh, what did I get it wrong? I got wrong the aspect of the components which filter the flow variables that go in and out. We are using target column here all over the place, and we removed it from the flow by creating this component. Make sure that in the component input, you get in the flow variable you need. And so here we are. We go back. A recording of this session will be available. I'm sorry, it's the first time I do this. There was lots of content. I should have maybe hide a few details. I hope you were able to follow me along in this interactive view that now should be working with anything. If you want to look, the solution is available in the workflow. It's right here. Monty, what do they say from the other sessions? Are they still working or are they done?
Yes, in 2 minutes we return to the main session.
What, sorry?
In 2 minutes we return to the main session.
Okay, 2 minutes. All right. I have 2 minutes to take any questions. The component, the exercise, we completed them all. We are a bit of behind track. And whenever they want us to go back in the main session, tell them that they can trigger, and then we go all back to the main session. So this is now working for any models. It's all about flow variables, switches, and capture nodes, and a bit of loop nodes when the things get a bit out of hand. What do you guys think? Please give us feedback. So chat, good work. Okay, thank you. Ooh, all breakout room will close in 56 seconds, guys. So we're gonna go back in the main room, but if you have any question, wait until then so we can receive your questions. Thank you for staying with us. And reach out to me via email if you need help in the forum, and I will be super happy to support you with your own components making. All right, click leave breakout room and we go back to the main session, guys.